In this work, to be published in NIPS 2017, we propose a screening rule to dramatically increase the efficiency of the structural learning of Ising models. To begin with, the joint PDF of a multivariate random variable x is defined here. Notice that the z theta denotes the partition function, which is extremely hard to calculate. Accordingly, the structural learning can be formulated into this optimization problem. However, because of the existence of the partition function, directly solving for theta is an NP-hard problem. To deal with this, we now propose a screening rule. So what is a screening rule? A screening rule is a technique to detect the zeros in the optimal solution with only a little and even minimal calculation. For example, in these three figures with the same number of nodes, the right one has more edges and thus is denser. The proposed screening rule can detect most of the zeros in theta very efficiently. Based on the results of the screening rule, the further structural learning will be very easy and fast. In fact, there have been various of screening rules for different models. However, notice that the screening rules for discrete generative models, which are arguably the most computationally intractable, are still absent. Our work will fill this important blank. To illustrate the screening rule, we first define block and blockwise. In this example, node 1, 2, 3 constitute a block, and 4, 5, 6 constitute another block. We call this structure a blockwise structure. Then, our screening rule is formulated into inequality 1. If ij satisfies inequality 1, we can conclude that theta ij equals to 0. Notice that this calculation is very simple and efficient. The screening rule is not guaranteed to detect all the zeros in the optimal theta, but it can be combined with other structural learning methods to achieve this. And this process will be much faster. Here, we list some structural learning inductive principles that can be combined with the screening rule. We will focus on the first two as an example. In this part, we study the performance of the proposed screening rule when combined with the node-wise logistic regression method and the pseudo-likelihood method. To begin with, we simulate the samples for these four networks. Then, we run pseudo-likelihood method, the node-wise logistic regression method, and the methods combined with the screening rule to the simulated data. The runtime is on the left, the lower the better. We can see the yellow and orange lines indicate the methods combined with screening rules, which are much faster. Also, we compare the EUC of the ROC curve for the structural learning to demonstrate the accuracy of the considered methods. The EUC achieved by the methods using screening rule is nearly the same as those without screening rules. As a result, the proposed screening rule can provide huge efficiency gains with little loss in accuracy. That's all. Thank you.